Silvia mentioned, in this webinar, we will review some data annotation basics and additionally some intuition about AI model deployment in cloud computing infrastructures. My name is Adrian Colomer, and I'm in charge of the first part of the webinar about data annotation, and this is the outline we are going to follow. Okay, so first of all, we have to briefly explain what are data annotations. Okay, so in general fields, when we have data, okay, there is important to have some guidance about the data, some knowledge about categorization, location, and some other parameters from this data. And this is the so-called data annotation or data labeling. So labels, tags, or any metadata assigned to this raw data, making this data more understandable, okay, and providing extra information of this data, basically. And of course, this process is very useful to train different machine learning models, in which we have to transfer our knowledge, our human knowledge, to a predictive model. So for this reason, we need this data annotation procedure. In fact, when we want to apply some supervised learning, okay, techniques. So for this reason, of course, with these data labels, okay, we are providing the machine learning methods, of course, or we are providing the power of learning to recognize some specific patterns and make decisions from the data. It's a very, very critical point, of course, for supervised, for fully supervised methodologies, and also for semi-supervised. Okay, of course, the category of unsupervised techniques are out of the scope of the data annotation process. Additionally, we have to, when we are annotating, when we are labeling, we have to assure some quality in our data, and in the next slides we will cover some quality checks that we have to cover or to ensure in order to provide non-biased information to our predictive models, because otherwise, if we are introducing some incorrect label data, it will act as noise to our predictive model. Okay, so it's quite important to follow like a pipeline or procedure in order to guarantee that some data quality annotation. Okay. So in this sense, the idea is, first of all, to introduce which kind of data we can annotate. Okay, so because, as you know, in real environment, in real scenario, we can have in front of several or different data modalities, okay, from, for example, structured data or imagery, 1D signal, for example, audio, some signal from any kind of sensor, or in fact, a video that is composed of a series of different images. Okay, so all of this data could be included in an annotation process. For example, here in the slide, we can see how we can annotate some text, for example, in which we have to categorize with some labeling. Of course, first of all, we have to define the ontology of the labels, and from that we can select some word or a set, a batch of words, in order to assign them a specific data label. Okay, in order to, for example, if we want, I don't know, create or to train a predictive model, for example, for emotion recognition from text. Okay, so first of all, the process is to create a data set in which we are able to annotate and to manually identify the text responsible of evoking that emotion. Okay. So additionally, we can, of course, deal with audio, in which we can select a piece of audio in order to provide a tag, okay, or a label. Image, of course, we can annotate image, or we can label video also. In this kind of data, image and video, we have a lot of possibilities, okay, of annotation, and this is the focus of the next slides. Okay, so first of all, when we are working with image for image analysis in general, we can face different tasks. Okay, so the first one, or the best, the most well-known task is classification. Okay, image classification that could be, for example, binary or multi-class, okay, or even multi-label classification. So here the idea is just to provide information during the annotation process of which categories of which objects are present in the image, okay, and annotate the image according this information. Okay, so for example, here if we have facing a multi-class classification problem, okay, the first part is to annotate our data set, and for example, the first image is this image in which appears a dog. So the idea is to label it as a dog. Okay. Of course, for binary or multi-class classification, multi-label classification could accept more than one object, more than one class. So, for example, in this photography, in which we can recognize a dog and a cat, this image belongs to two different classes at the same time. Okay, so this is the meaning of multi-label classification. Additionally to classification, we can find other kind of tasks when we are facing image analysis in general. In classification, the unique information we are providing is the presence or absence of the classes we are interested on. But additionally, we have object detection and segmentation. Okay, the task of object detection is directly to not only provide information about the presence, but also about the location or uncount. Okay, so the idea here is to locate with a bounding box. Okay, a bounding box is just a rectangle, like a window surrounding a rectangle window surrounding the object under study. Okay, so a part of providing the information of, in this case, the object that are bananas, we are providing information about how many bananas are in the images and where they are placed. Okay, so this is the idea of object detection. Additionally, we can also face the task of segmentation. Now, the idea is not only providing a bounding box surrounding the image, but also, instead of that, the idea is to pixel-wise delimitate the objects under study. Okay, so the idea here is we have in this image 4 bananas. So for each pixel in the image, we have to provide information, okay, about if that pixel belongs to a banana or not, belongs to a pixel of the object banana or not, okay? And additionally, we can provide more information. For example, if we are interested on also segmenting the hands in this image and so on. But the point here is we are being more precise than object detection, okay? Because we are interested on delimiting in a pixel manner, okay, the different objects in which under study. And the extension of segmentation in general, we can face two types of segmentation: semantic and instant segmentation. Okay, in semantic, all the bananas belongs to the same category or the same tag. But here in instant segmentation, the difference is that for each individual, for instance, we will set a different label, okay, a different category. So that's the point, and that's the difference about instant segmentation and semantic segmentation. Okay. So now it's time to present some challenges in data annotation. For any procedure of data annotation, we have some challenges to face. First of all, the scalability, okay, scalability, in which, of course, the fact of annotating large data sets can be very time consuming and prone to errors, okay? Here, maybe we have a lot of images to annotate. For example, if we go to a medical domain in which we need the presence of expert clinicians to make these annotations, of course, we are consuming a lot of time because if for large data sets, depending on the size of the objects of interest, this could be more time consuming, okay, and prone to errors because as many images we have, okay, we are more susceptible to make some mistakes. Additionally, subjectivity is another field, another challenge to solve because, of course, we have always ambiguous cases. In the case of sentiment analysis, of course, some positive or negative reviews are quite clear to label them, but what happens with neutral reviews? Depending, for example, on the annotator, some annotator could tag this neutral review as positive, or another could tag the review as negative. Okay. Additionally, the domain expertise that we talked some minutes ago, in which we need a specialized knowledge. Okay, for example, medical imaging this is another challenge because, of course, for example, people with a lot of expertise, okay, have to invest a lot of time doing this kind of tasks, and are crucial because, of course, the success of the trained predictive model depends on this specialized knowledge, okay, and the transference from clinicians, for example, or from experts in some specific industry field, okay, this transference to the model in terms of annotations, okay. Of course, we have also to guarantee some uniform labeling, okay. For example, defining some annotation protocols and so on, in which different persons could follow this protocol in order, of course, to provide uniform labeling. Okay, that's also important. After that, we also have to guarantee legal and ethical considerations about GDPR compliance and so on. Okay. Well, nowadays we have the advantage of automatic annotation. Okay. Currently, there exists a lot of trained or pre-trained models that could help us as humans to annotate data sets. Okay, so the idea here is instead of the human perform from scratch a data annotation process, maybe we can take in profit from the output of some pre-built predictive model in order to start from some called pseudo labels. Okay, and of course from that pseudo labels, that is the output of the inference of a predictive model, we can avoid a lot of time performing this annotation process. Okay, so here in the scheme, in the diagram, we can see that some raw data could be auto-labeled by an AI. Okay, and with this model prediction, we are building a preliminary label data. This preliminary label data could be reviewed by a human. Okay, and correct, if necessary, some labels. Okay, after some loop here, we are able to obtain the final label data. Okay, so this is the idea, to work in a collaborative way, humans with the different AIs. Okay, and always assuring some, as I mentioned before, some specific quality, okay, and cost-effective annotation. First of all, some techniques in order to guarantee these aspects could be developing or defining an annotation guidelines, okay, and training, but the most important part, annotation guidelines, in order to guarantee or to be sure that all the persons involved in the annotation process are performing the label process in a consistent way. Okay, so that's quite important. Additionally, we can check after data annotation the inter-annotator agreement with some metrics that we can find in the literature, for example, the coherence kappa and so on. We are able to measure, to quantify the agreement of or between annotators. Okay, and that's quite important because we can also compare our model with the agreement with one or with the different annotators. Okay, in terms of quantify the goodness of our predictive model. Okay, another point to take into account is the collaborative way, or the collaborative property in data annotation. Okay, of course, the idea is to provide to the model the more precise knowledge. Okay, and maybe if only one annotator is performing the process, the model could be biased. Okay, so the idea here, the idea in crowdsourcing annotation is to involve more than one person in the annotation process in order to reduce the bias transferred to the knowledge. Okay, and for this purpose, there exists different crowdsourcing platforms for doing this annotation. For example, one of them is provided by Amazon and is called Amazon SageMaker. Okay. Well, another important point is the so-called active learning. Okay, active learning is this collaborative process between machines and between humans in order to reduce the cost-effective annotation. Okay, so if you remember the previous scheme in which we can make use of an AI model in order to obtain a first pseudo label annotation. Okay, and after that, with this annotated data set, okay, we can ask for human feedback. Okay, for human feedback about data annotations. Or for example, in active learning, the idea is from the data annotated by the AI, the idea is that human could revise the cases in which the confidence from the AI is low. Okay, the more the cases, the most controversial cases in which the AI is not sure are the cases that the human has to re-annotate, or at least to modify that annotation, because of course the AI is not confident about its decision. Okay, so this is called active learning process. And finally, we can introduce more data, and we are, of course, for example, in different there exist key fields in which obtaining data is not straightforward. Okay, and more important, obtaining data with quality annotation. Okay, so for this or in these fields, we can make use of synthetic data generation. Okay, so the idea behind this is we are able, with some deep learning techniques, okay, generative deep learning techniques, to generate data, but not only to generate data, even we are able to generate data condition to a particular label or a particular text, or we can condition the generation of, in this case, images, okay, to another data modality. Okay, so in this case, for example, in the image, this is a work from CBB Lab, and we are able of creating some histological tissue, but not in a random manner. Okay, we are conditioning here the generation of this histological tissue depending on the grade of a cancerous depending on the grade of a cancerous pattern. Okay, so for example, here we are able to create a prostatic tissue that presents a grade 3 according to the Gleason scale. So in this way, we are able to create not only synthetical data, but also additionally with the corresponding label. Okay, so we are like generating label data. Okay, and this is also quite useful. The architectures of in terms of generative deep learning are well known. Generative adversarial networks, or nowadays the so-called diffusion models. Okay, if you are interested in more detail. Okay, so in order to finish my explanation about the intuition of annotation procedure, here we can see different annotation softwares in which you can, of course, you can use in order to annotate your own data. For example, the first one is Prodigy. Okay, with Prodigy we can annotate any kind of data modality, text, images, video. Okay, and Prodigy uses active learning to prioritize the most informative samples for annotation. Okay, as I mentioned before, the most low confident data examples are transferred to the human in order they can, or the human can provide feedback about the annotation. Okay, but we are avoiding time because some AI models are embedded in the platform. Additionally, RoboFlow is a quite common software to make annotations. It works very well for image analysis. Okay, we have a lot of functionalities. In some minutes, we will visit in a quick demonstration. Okay. Additionally, Pixnormus. Pixnormus is a home-made annotation software here in CBB Lab. Was developed in CBB Lab. Now is being exploited by artificial intelligence. So the point, or the main important point of Pixnormus is that this software can deal with gigapixel images that occupies a lot of pixels, okay, and in this is consuming, for example, one image between 1 and 2 gigabytes, okay. And of course, segment anything model is not a software, but it's a model that from which we can take profit in order to perform some automatic annotations. Okay, there is some demos, in the website of Meta, in which we can interact with the models. Okay, we have two versions, SAM and SAM2. With SAM2, we can extend the annotation, the semi-automatic annotation process to videos. Okay. Okay, so just to finish, I'm going to perform a very quick demonstration. Okay. First of all, the idea is to visit RoboFlow just to show you the different functionalities this software can provide us. Okay, so here we can, of course, it's quite important to know how to deal with projects in RoboFlow. We can build projects inside the projects. We can invite other people in order to perform some crowdsourcing level techniques, and we have a lot of functionalities. Okay, in fact, we can train models, okay, from here, from RoboFlow, and here just one example about how we can detect or label in a semi-automatic way, okay, a data set. For example, this is an image belonging to a data set of persons and cars, okay, and here, for example, we have some functionalities. We can manually, for example, segment a car in this is the bounding box manner in which this is very useful to train an object detector. Okay, but also instead of the manual functionalities, we can accede also to some AI assisted functionalities in which, for example, with this smart polygon, I can select some car and directly I'm obtaining, okay, the automatic annotation of this red car. Okay, so there is more functionalities. For example, here we can use some public models or our own models, okay, in order to involve some different AIs to assist us in the annotation process. For example, I can use this public model from this data set of people, okay, in order to detect the people, okay, and here the RoboFlow is able to load the model and perform the inference process in order to return us some annotations, okay, some annotations that are predicted by the model. Okay, so that's more or less the different functionalities. Of course, there are a lot of functionalities in RoboFlow, but if we are interested on annotating images, okay, RoboFlow is a good option, okay, if we want to use a free software, okay, and publicly available software. Okay, additionally to RoboFlow, I'm going to present Pixnormus in just 5 minutes. Pixnormus is this software that was developed by CBB Lab, okay, and the idea of behind Pixnormus or the potential of Pixnormus is the ability of handling with gigapixel imagery. Okay, for example, in histological imaging, okay, histological imaging deals with some digitalized biopsies of different organs, okay, and these digitalized images are very consumes a lot of resources in terms of hard drive disk and so on, okay. For example, we can go to a project in which the idea of Pixnormus is to navigate in a quick way, okay, along these images, okay, these gigapixel images, without losing quality, okay. And here we also have different, okay, tools in order to annotate. Okay, for example, this kind of tools, and we are able to call some AI models embedded in the backend in order to assist us in the annotation process. Okay, so for example, here we have some candidates to tumoral areas. Okay, and these tumoral areas, for example, we can call another model in order to check if they are benign or malign areas and so on. So here we are introducing AI models additionally in the backend of the platform in order to assist humans with the tedious annotation process. Additionally, for example, with Pixnormus, we can also extend Pixnormus to a lot of fields. For example, we also have projects about coast in which we have some satellite imagery, okay, that are also gigapixel photographs. And here we can navigate additionally. We have a lot of functionalities. As I mentioned, for example, we can annotate by polygons, okay, if we are interested on, or we can, of course, making zoom, rotate the images, okay. And here, for example, the idea of the project was to automatically detect the water on this kind of images. Okay, also for vegetation purposes, okay, in order to detect different kind of vegetations and any kind of course, Pixnormus can deal with any kind of images, okay, of typical images with low or medium resolution, but the powerful of Pixnormus is working with high resolution images, okay. So finally, just to comment that here we also have the properties about smart management of the project, some hierarchy in the role of users, and so on. Okay, so that's all from my side. Now is the turn of my colleague Juan in order to talk about the model deployment in cloud computing infrastructures. Thank you so much.
Okay, thank you, Adri. And my name is Juan, and I'm going to show you the second part of this webinar that is about how the tools we need to program or develop the different IA models. Okay. 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 First of all, we start with basic concepts of the deep learning models that, for example, defining what is the deep learning. So basically, the deep learning is the way that we need to solve the problems imitating the human thinking and logic. And to resolve these kind of problems, we need the so commonly used neural networks that are used to process the data as humans do. There are different problems that are required for different neural networks. For example, the image classification problem that usually we use the convolutional networks, and for the speech recognition problem that we use typically transformers. But one of the most high drags for the neural network is the highly demanding resources that they need to compute that amount of data. But all these operations are independently. For example, the matrix multiplication, the operations row column involved are independent between them, or the convolutions involved in a position of a kernel. So based on this slide, now we will show the different processors we have to develop the deep learning models. Okay, first of all, we have the CPU that, as you can see, has a low number of cores and are used for the general operations, like the playing video games or open a document or anything. And then we have the GPU, that is the graphical unit processor, that, as you can see, is used for parallelized operation and has a great number of cores than the CPU. And the mathematical operations are in deep learning are perfectly for parallelization because they are independently, as we see in the last slide. So for this reason, one of the best options to run these models are the GPU. Okay. So here I want to show you a video about the difference between the GPU and the CPU, how to process this data. Maybe you cannot listen the audio, but it's enough with the video. So in this video, this machine to paint simulate how the CPU process the deep learning model. As you can see, it is used for very simple tasks. But this other machine that we are going to see is used to emulate the GPU. So as you can see in the video, let me check. As you can see, the image that can generate is more complex and it can do it in a very low time. So for this reason, the GPU is best than the CPU. So turning back to the presentation, now that we know that we need a GPU to perform all our models, now I want to show you what the different companies they are designing the GPUs. First of all, we have the AMD graphics with its platform called ROCm. Then we have the NVIDIA with its platform called CUDA. And finally, the Intel graphics GPU, that is the platform is called Intel One IP. And which one is best? The best one nowadays is the CUDA because it's the most efficient platform nowadays and comes with a lot of libraries optimized for deep learning models. So for this reason, the GPUs that we need to use for the development of the deep learning models are the NVIDIA GPUs. Okay, now I want to show you a little state of art of the current GPUs of NVIDIA. So as you can see, the 4000 generation has all these kind of models of GPUs, and this is the features that you want to you need to see in order to compare with the different deep learning models. Okay, one of the best indicators of the of a good GPU are the CUDA cores and the memory size. As more we have, the best. So as you can see, the best one here is the 4090, but obviously is the more expensive of them all. So you need to find a balance between these two features and the price. And then we have the newest generation that is from this year. And you can see that the CUDA cores and the memory size has increased in this generation, especially in the 5090. Obviously, the price also has been increased. And here in the slide, you have a little theoretical comparison between these series and the previous one. Okay, but NVIDIA now does not only build GPUs, but the whole system as well, called the embedded NVIDIA system. This is the best option if you want to develop the deep learning model, because you have a lot of GPUs and a lot of power. This parameter tell us about how the efficient and how is the performance in this kind of machine. As bigger, the best. So here, for example, we have in the DGX H200 that we have 8 GPUs of 141 gigabytes each GPU. So we have a lot of VRAM and a lot of processors. The only problem of these kind of machines are, as you can see, the price. Not all the people can afford for one of these machines, even our department of the university. For this reason, we have more cheaper options like boards, like either Jetson boards that obviously have pure power, but the cost is more rent. Okay, and this is like the middle one. We have a mini server that you can buy for 3,000 euros and has more power than the boards, but less power than the server options. Now here we have the civil app structure of the servers. We have 5 servers especially developed for the developing of the deep learning models, and one for inference, and other for this web application that Adrian has shown you in the last part, in the previous part. Okay, and here we have a picture of our develop. Okay, so here the last one I want to show you is the NAS server, or the data server. That is where all the computing server goes to recompile and write the data, code, the data sets, all you can see. And basically, a data server that is called NAS is used for store all the relevant data, models, results, as I showed you before. All the data servers, all the computing servers can access to that server, and there is a lot of brands, as you can see, but one of the most used nowadays is the QNAP and the Synology brands. One thing to consider is that the number of storage capacity that the NAS can afford to the data. This parameter is estimated according to the base that you can see here. As more base, more capacity we can have. And then we have a technology, software technology that can combine all the hard drives as a one in a logical drive. So you can access only to one drive instead of 8 or 16. That is more comfortable. Okay, so now I explained you all the hardware part. Now we are going to show. I'm going to see all the software we need to deploy the deep learning model. Okay, so the programming languages we need to use is Python, because it's one of the most widely used, because it has a lot of libraries and frameworks especially dedicated for AI, has a strong community to ask in case of errors on all the things, and is platform independent. And the IDs for deploy this for programming this Python is Visual Studio Code and PyCharm. Okay, so now we're going to show you how to set the environment to program the deep learning model. Okay, before explain you the environment, we need to see the different issues that we can show when start a new environment. In the same server, we can have a lot of models. So each model needs its own libraries to work properly. All the different models has different libraries and has all different libraries. So changing the libraries will lead to a failure to one of the models. So adapting the model under dependencies. So we need to adapt the models and dependencies in order to apply all these changes. Okay. So in order to avoid all these problems, okay. So we have a problem that is that a great number of libraries in the same server can lead to incompatibilities and cause that the models crash. So the only solution is to isolate the models under dependencies. One of the most common solutions in the CV lab is to employ Docker. This Docker is a software platform that is used to execute containers. And a container is a unit of software that is used to isolate all your dependencies and all your code. So one model will be equivalent to one container and all its dependencies that will be isolated from the other models, avoiding the problem that we see in the last slide. Okay. So all this way to procedure is that the way we in the CV lab we use. So I'm going to show you how are the steps all our researchers follow to develop the deep learning model. So first of all the researchers debug each code in its local machine, that each one has its own CPU. And once the code is totally debugged and has no errors, they can use a tool called Slurm to communicate with the servers we have. This Slurm is a job schedule that is used to execute all the code in an efficient way to take profit or take benefit of all the GPUs in the servers. So as you can see, we have in this case two queues or two partitions that is for the servers and for the big server in our place. The researchers can schedule their jobs, and if there are no any job or there are a lot of resources to give, they are immediately used. And this can be done in any way, as you can see, taking the place of each of the resources till all the resources are full. Once all the resources are full, the the next jobs or the next models to execute are in a queue, waiting for the next or for the last job to be finished. Once a job is finished, automatically the next takes its place to take benefit of the tool. Okay, so in my case, we finish my part, and if you have any questions, you can use the chat, and this is all.
Thank you very much, Adrian and Juan, for this interesting and complete presentation. So now, as Juan has mentioned, we would like to open the floor for any questions from the audience. So if anyone has something to ask, please write the questions on the chat so that Juan and Adrian can answer them. Mm. We have a question from Alejandro. Can you see, Adrian and Juan, the question? Or he's asking about...
Sorry, yes.
Okay.
I think it's for me. Alejandro says, in Pisnormus, could the user improve the automatic model by re-annotating some low confidence cases? Yes, in Pisnormus, right now we are developing the part of active learning. So, of course, we are able to, from as you saw last minutes ago, the idea was to we are able to obtain the output of the some artificial intelligence models embedded into the platform. Okay, and from that, the user can modify the annotations, etc. The part we are currently developing is from that modifications, from that human feedback provided by the expert annotator. The part we are developing is to retrain, to automatically retrain that model, and the version of the model can be updated directly in order to close the loop of active learning. So we are, in fact, we are working on that. Thank you for the question.
Another question.
So here,
for Adrian.
Another question. What are the advantages of Pisnormus over other annotation software? Okay, so the main advantage compared to other public softwares, for me, the first one is the ability of navigation in an efficient way when we load gigapixel images, when we load images with very high resolution. Okay, this is the most important part, and of course the models trained and embedded on the backend works in a patch-wise manner, because of course we cannot create models from images with this size directly. We have to patch to patch in different tiles the image, and to create a patch-wise predictive models. So I think there is no other software available nowadays in the market that can provide this property. In fact.
Thank you, Adrian. Are there any other questions? If not, I think we can conclude here. So if there are no questions, we can finish here. Thank you again for joining us today, and don't forget to follow us on our social media to stay updated on the project and to get information about the next upcoming webinars. Thank you very much.
Okay, thank you so much. Bye.
Bye.
Okay, bye.